Let's look at the notion now of equally likely outcomes in probability. And we'll go through this example together. So a letter is chosen at random from the word probability. Part A, list the sample space. And part B, calculate the probability of choosing the letter R and the letter B. Okay, so I might just list the sample space over here. Okay, so the sample space is, okay, let's see. So if I'm going to be drawing a letter at random, now random means that each of these letters individually have an equal chance of being chosen. So if I just put all those letters, basically put them on a bit of cardboard or something, or on a counter, put them in a bag, put my hand in the bag and drew out one of these letters or one of these tiles, there's an equal chance of choosing one of these cards or tiles. Let's have a look at the sample space. So we have a letter A. Okay, there's a letter B. Okay, we have the letter I. Okay, try to list them. If they're letters of the alphabet, I try and list them in order where possible. We'll have the letter P. In fact, we've got the letter O first. Okay, so we've got letter O, P, we've got R, and we've got T, and we've got Y. Okay. Now, what's important to note is that there are 11 letters in the word probability, but in the sample space, I've got 1, 2, 3, 4, 5, 6, 7, 8. I've only got 9, but we've got to be very careful here that when choosing a letter from the sample space, though, the probabilities of choosing one of these letters may not be the same. While it's equally likely that I'm going to choose one of these letters if they're written on a card and put into like a box or a bag, well, as you can see, there's 2 B's, there are 2 I's, but they're not listed twice in the sample space because it doesn't matter which of the I's or which of the B's that you draw, it's the letter B that I'm interested in. Okay, so considering that there are more letters, more letter B's and more letter I's, it stands to reason that there's going to be a greater chance of selecting one of those letters. Okay, so let's have a look at part B. Calculate the probability of choosing the letter R. Now, we got the probability of choosing the letter R, is equal to, and this is why with probability, it's always I would highly advise that fractions are the preferred way of expressing a probability. You can convert the fraction into a percentage or a decimal later on if required. Okay, but by nature, probability is a fraction. Okay, so how many letters have we got to pick from in total from the word itself? We've got 11 letters, and one of those letters, is the letter R. Okay, so the probability is 1 on 11. Okay, so this is for part I. And for II, the probability of the letter B. Okay, again, it's out of 11 letters or 11 cards. So if you were to write those letters on a card, there's 11 of them. How many of them are the letter B? Okay, we do have letter B as one of the outcomes, but in the word itself, there's 2 of them. Okay, so the probability is 2 on 11. So you can see here that from this example, that choosing the letter B is twice as likely to occur as choosing the letter R.